Now we're going to go to tab 16 of subprogram 1, where we see the value of C set to 65, which is an ASCII capital A. And here there's a loop that it's going to go around 26 times, and each time it's going to increase the value of C by 1. Here is an instruction that takes the value in C and puts the ASCII character in the test page at offset I. So the alphabet is going into test page, one letter at a time. Then the next loop goes around and takes that character data that's in the test page and puts it into a list of values called ASCII value. Again, for any letter of the alphabet, from offset 0 to 25. Then it sets X to 10, Y to 40, that's the position where it's going to place this text down here. The color is going to be dark blue, the size of the font is going to be 48 points, 4 in the front meaning bold. Here it says it's going to write the text. Alright, we're going to see what happens. Here we see all the letters of the alphabet written across the page. Now we also want to check that the ASCII values were placed in ASCII value list. So we'll click the ASCII value list, and yes, we see 65 through 90, which is capital A through capital Z. Now we're going to go to tab 17 of subprogram 1. And in tab 17, what it's going to do is issue a talk to 62. The rest of this is just telling it to wait a certain count. The reason it wants to do that is because a sound can't be replayed immediately after it was played once. But we're going to go now to find where these sounds are. Where is talk 62? We're going to go over here to the bottom where it says sounds and click on sounds. Then we're going to find number 62 and we'll click on it here. Now we'll try some other sounds. Sound number 1. Sound number 2. Sound number 3. Sound number 4. Notice there are a lot of sounds you can use. Now I'm going to leave here by clicking the X in the upper right hand corner. That is sounds. Now we're going to go to tab 18 of subprogram 1, where we're going to learn about formatting numbers. First, sets Y to 20. That's how far from the top it's going to start. Sets the color to black. Sets the font to bold 15 point. Sets the value of V to 12,340,000. Then sends for I of 1. Next I 10 1. It's going to go around this loop 10 times. Each time it's going to divide the value of V by 10. Also, each time it goes around, it's going to fill a test page with blanks, ASCII 32. It's also going to turn V into a positive integer that is rounded and put it in U. Now it's going to use the 3 formats. The first format is the floating point format, which it says is going to have 10 positions, plus it's going to have another 2 that are given for the exponential part. Here it puts it at the beginning of page called test. Then it does another part, NUMD, which means assume decimal places. It's going to show it as 10 digits, then with a decimal point, and then 2 more digits. It's going to put that at test page at offset 25. Then it's going to do the third formatting, which it's going to put at test plus 50. That always has 12 spaces and puts the decimal point in the number. So they're not aligned up like the others are, the other 2 formats. Then it's going to put the line test on the screen, the 75 characters, 25 characters for each format type. Then it's going to add 20 to the Y position so that the next time it goes around, the next line is down 20 pixels. So now let's execute this. Here we see our number, 12,340,000. When it's in floating point format, the next one just says, well, now it's 1/10 of that, 1/10 of that, 1/10 of that. And when it gets down here, because it's in floating point, it continues to show the significant digits. It just says here, when you divide it by 10 again, well, there's 1 decimal point. We have to move it to left 1 because of the A says that. The B says move it over 2 times, the C move it over 3 times, the D 4 times, and E 5 times. So this is really 0.01. Which will we see over here? This is the one form that's just called num. This is 2 assumed decimal places. Doesn't matter. So what happens is it starts out showing the number with 2 assumed decimal places like it would be here, because you told it the last 2 digits are decimal points. So it treats it as an integer number with 2 decimal points. So it continues on down until finally there are no digits that it can show anymore because they're below. They're fractional parts. So here we have the 3 types: floating point, assumed decimal point, and just digits. This is tab number 19 of program 1. In this routine, it's going to do a pick, a PECK, and a PUCK. Each is going to select a value from a distribution. Pick will make 15 random selections from a frequency distribution with replacement. PECK will make 15 random selections from an equally likely distribution. PUCK will make 15 random selections from a frequency distribution without replacement. The frequency distribution for PECK and PUCK is value 1 should be selected 1/15 of the time, value 2, 2/15 of the time, value 3, 3/15 of the time, value 4, 4/15 of the time, and value 5, 5/15 of the time. Now let's look at the values selected. The first column here is for pick. The second one is PECK, where they're equally likely. And the third one is for PUCK, where it samples without replacement. For the pick, column 1, the chance of a 1 is 1 in 15. And you notice it never selected a 1. However, the probability of a 5 was 5 in 15, and you can see that there are several 5s. In the PECK column here, each number from 1 to 15 was equally likely to be selected. However, you see that since it's random, that isn't necessarily so. This is the PECK column. It samples without replacement. So, in 15 picks, there should be 1 1, 2 2s, 3 3s, 4 4s, and 5 5s. Now let's go back to the program and look at a special case down here at the bottom where it's going around the loop. If when I is 10, it's going to fall down here and do this CSET operation, where it's going to copy the PECK data and put it in a new distribution. It knows which distribution because the seed number matches. Here, 2 plus S matches the PECK seed, 2 plus S. Now we're going to look for this frequency distribution at list D plus 20. So we'll go back to executing the program. We'll look at data and we'll select list D. Here we see that the newly created frequency distribution says there are 5 possible values, of which the sum of them is 5. So here 1, 2, 3, 4, 5. Remember, the values in the frequency distribution were such that there were 5 values, 1 through 5. They sum up to 15, which is 1 1, 2 2s, 3 3s, 4 4s, 5 5s. The sum is 15. But after 10 selections had been made, the frequency distribution that it copied says there are 5 different values still, but there are only 5 left. 1 here, 1 here, 2 here, none here, and 1 here. You should go to the glossary of terms to learn more about frequency distributions. While programming, get information from the glossary by clicking Info. Thank you for watching.